Alright, hi there. So this lesson that I'm going to teach today is going to be about the periodic table and the periodic trends that we have on the table. So a few of the basic trends are going to be electronegativity, atomic size, ionic size, although that doesn't necessarily pertain to the periodic table itself, but that will be included. Ionization energy, and then lastly, reactivity. Alright, so on the periodic table, as you notice that there's going to be up and down are going to be the periods, and then across the periodic table are going to be the groups. So as you go down, if I can write on this, alright, so as you go down, those are the groups, but they go 1 to all the way to 18. Now, if you look at the top, it says 1A, 2A, and then you get the B's in the middle. The B's are something separate from what we really focus on. Mostly what we do is we focus on the A groups for your periodic trends, but the B's are included. They just don't necessarily act appropriate all the time. So the first periodic trend is going to be electronegativity. Electronegativity is the measure of your attractedness to electrons. And the way that that works is it works inversely to the atomic size. So we have the highest values over here, electronegativity for fluorine, and we have the lowest values for francium. And the reason, again, for that is basically it's based off of atomic size, but one of the kind of common core concepts in dealing with atomic size and electronegativity. It's how strongly you're attracted to your electrons, and again, it's based off of size. So, like I just pointed out, the atomic size is something else that we have to take into account. So atomic size is going to be inverse to electronegativity, and it's going to increase as we move to the left and as we move down. And the reason for this is that as you add electrons to the atom, it increases in size out and out and out and out. And this is an important concept to keep track of, because it's going to pertain to the electronegativity and how closely attracted to the neighboring electrons that you're going to be attracted to, as well as ionization energy in dealing with the electrons that you are attracted to for your own electrons. So again, as we move left and down the periodic table, you're going to increase in atomic size. So the smallest atom will be helium, and the biggest one will be francium. Now, with the last concept, electronegativity, we say that fluorine is going to be the most electronegative, and the reason why the fluorines and specifically the halogens in general are very high in electronegativity is because they're one electron away from becoming a complete octet, which would be something that we'll talk about at a later date. But electronegativity is always highest the closer you get to becoming a noble gas, and noble gases are in the last column. Alright, next, so ionization energy we briefly talked about. Ionization energy is the energy that it takes to release an electron. So it's the energy that you would have to add to a atom to rip off an electron. Now, it could be an ion as well, that you have multiple ionization energies for different atoms, but we'll keep it at that for today.